Okay, so we're going to look at example 4. So now we have a series. So the first thing we want to do is we just kind of want to write a function that describes a sequence. So in this case, I'm just going to kind of figure out what's going on here. So let's see. Looks to me, see if you agree, that I could write each of these as I could write the first one as 25 times 1, 25 times 2, plus 25 times 3, so on and so forth. So from here, we can kind of see what's going on here. What's going on here is our function, or our, that the function that creates the sequence of 25, 50, 75, 250 is just going to be 25 times, I'm going to use I this time. And let's just check. If I plug in 1, I get 25. If I plug in 2, I get 50. If I plug in 3, I get 75. Looks good. So from here, what we're going to do is we're going to start jumping over to our series. So our series is we are going to start from 1, and we're going to plug things into what we just found, right? So we're going to take our series, and we're just going to start plugging in numbers. So we're going to start at 1, out comes 25. Plug in 2, out comes 50. Plug in 3, out comes 75. The next thing we need to know is, where does this thing end? Well, notice it ends when the output is 250. So we need to figure out, where is the output equal to 250? So what we're going to do is we're going to take our function. I'm just going to kind of rewrite a little bit. I'm going to say the AI equals 25i. And now what I'm going to do is I'm going to replace AI, that output, with 250. From here, we can just solve, and we can kind of quickly notice, I'm going to go this direction here, a 10 equals I. So that's our upper bound, and we should check it. Again, if I plug in 10 into this function, notice the output is 250. So this right here will produce that. Now that's a finite sequence. Notice how it has a beginning and an end. Let's look at an infinite sequence. So again, same thing. We are going to write, an infinite series. I said sequence, let's say series. So the first thing I'm going to do is I'm just going to write the sequence. So let's see what's going on here. In the numerator, notice it's just 1, 2, 3, 4, 5. So I'm just going to use I, right? Because when I plug in 1, I get 1. I plug in 2, I get 2. Notice the denominator is always 1 greater. So I'm going to do this. And again, quick check. If I plug in 1, I get 1 over 2. If I plug in 2, I get 2 over 3. If I plug in 3, I get 3 over 4, so on and so forth. So now let's write our series and summation notation. So we're going to start at 1. Our function is I over I plus 1. But now where do we end? Well, we don't, right? This says we go on and on forever. So we're literally going to stay with that. We're going to say, hey, look at us. We're going on and on forever. And we're going to note that by using the infinity symbol.